So they said fx is transformed to get g of x and h of x. So we are asked to find the coordinate of b. The coordinate of b is just the point of intersection of gx and hx. So we need to get the two functions and equate it together. So, but first of all, fx is the parent graph. We know for any exponential graph, it's either this way or that way. So they intersect at 0, 1. As the y-axis is 1. This is y equal to a raised to 4x, where a is greater than 1. Why this is where a is between 1 and 0. So that's it. As you can see, fx was this, and also gs is also that, but we transform fx to get g of x. So, and again, you have to know something, that if there's what you call horizontal and vertical shift. So if you have y equal to a function fx, and you later have another function y equal to plus or minus a plus or minus, okay, plus, but we don't need reflection here. So we have fx plus or minus b. This plus. So we know that a is a vertical shift. Either you shift down, that's negative is down, positive is up. While here b is horizontal shift. Horizontal shift. So it's either to the left or to the right. So positive is left, negative is right. That's that gx and hx are gotten from fx. So what do you have to say? So if this is a raised to 4x, as you can see, hx will be 1 over a. Do you get? Because a must be between that. So hx will be 1 over a raised to 4x. Since a is greater than 1, so and for it to be 0 and 1, for it to be this graph, so it must be 1 over a. So that's the logic. Or sometimes they write it as a raised to 4 minus x. So we're on the same track. So again, for g of x, if I shift up, because the major points here on this graph, the major points are on this major grid line. For this is a major point. This is also a major point. For g of x, this is a major point. There is no other one in the grid line. For the fx, this is also a major point. So we're going to use these 3 points. So if we use this one to get this, that's a, x and hx. So we'll use the two too, because if you move up, if you move fx 1 unit up, you get gs. So I'm saying that gx is now 1 plus a raised to 4x. Yes, there's no horizontal shift, whether left or right. So we need, that's what we need. So for us to get coordinate of b, so at b, gx and fx and hx, you equate the two. That's at the point of intersection, the two must be equal. See it. So what am I trying to say? We now have 1 plus ax is equal, yes, is now 1 over ax. So but the little problem now, we need to get the value of a so that it will be easy for us to solve. But we need to get an actual answer. How do you get it? That's where we use this point. Yes, that's how we use it. So as at minus 1 comma 5, you see that hx, we know that is a raised to a minus x. So at this point, y is 5 and x is minus 1. So what do you have to say? So here a is 5, therefore a is 5. So let's go back and solve this. So this means, let's move to another page. So since we've gotten the value of a to be 5, you know that this means 1 over a raised to power x, 1 plus a raised to power. So we have that 1 plus a is 5, 1 over 5 raised to power x. So if you multiply both sides by 5 raised to power x, we now have 5 raised to power x plus 5 raised to power x all squared. That's the same, equal to 1. That's multiplying both sides by 5 raised to power x. So this is a quadratic equation, because if you let 5 raised to power x to be y, you now have y plus y squared equal to 1, which is y squared plus y minus 1 equal to 0. So solving using quadratic formula. So y will now be minus b. Do you remember quadratic formula? That is, if you have as squared plus bs plus c equal to 0, to get x is now minus b plus or minus b squared minus 4ac over 2a. So that's what we are using here. Our x is y, so b is the coefficient of x. So we have minus 1 plus or minus b squared, which is 1 squared minus 4, a is 1, c is minus 1, over 2 times 1. So we have that y is now minus plus or minus 1 plus or minus, this is 1 plus, that's 5 over 2. So we've gotten the value of y here. So we go back. But we know that, y here, y, the exponential function must give you a positive answer. Yes. Just know that any exponential function must be a number greater than 0. Check it. Any exponential function must be a positive number. From the graph, as you can see, the graph, as you can see from here, you see that the y value must be a number above the x-axis. Yes. So it will guide our solution. What am I trying to say? You see that the negative part of this will not be included. Yes. Because this will turn to a negative number if we leave this. So we exclude this. So let's now continue. We now go back. We substitute y as minus 1 plus square root of 5 over 2. So from here you see that x, relationship between logarithm and indices. If the base goes over, is now base 5 minus 1 plus root 5 over 2. So we've gotten the value of x. So to get the value of y, we choose between hx or gx and substitute the value of that. You choose between this gx and hx to substitute the value. So which one is better? Yes, use hx because it has nothing like 1 plus. So to make our conclusion. So to get the value of y, because we are looking for coordinates of b, so x and y, we've gotten the value of x. We need the value of y, therefore hx is a raised to power minus x. No, this is also 1 over a raised to power x. They are the same. Laws of indices is now equal to 1 over a raised to power x means 5 raised to power x, and we know that 5 raised to power x is minus 1 plus root 5 over 2, which is 2 minus, we can write minus 1 plus root 5 as root 5 minus 1. So if you rationalize, to make it easier, if you rationalize it, the conjugate of that is 2, that's root 5 plus 1. Why this is difference of 2 squared? So I rationalize by multiplying up and down by the conjugate of this, which is root 5 plus 1. So we see that we'll have this 5 minus 1, 4 in there. So we have root 5 plus 1 over 2. We'll see that b that we are looking for, the coordinate is x, which is log 5 minus 1 plus root 5 over 2, comma, y, which is root 5 plus 1 over 2. So that's the coordinate of b we are